Hello, pre-calc class. Mrs. Levensiller here. And for the next two classes this week, we're going to talk about solving trigonometric equations. So far, we've really focused on the unit circle. And so we're starting to think about, we're going to start graphing these trig functions separately. So you want to think about almost pulling the unit circle apart. So instead of thinking about those points as both a sine and a cosine, if we took just the sine values off the graph, what would that look like? Or just the cosine values off the graph, or just the tangent values, etc. So we're going to get into graphing those pretty soon. But today we're going to focus on solving them. So just like if I solve a polynomial, so let's say I had x to the third plus 4x squared minus 6, all right? If I am solving this polynomial here, well, if I asked you to find the solutions, you would really be looking for the zeros, right? So negative 3.5, negative 1.5, and 1.1, those would be the solutions to this equation, this particular function. And we're assuming at this point this is equal to 0, right? So when we graph this, we're looking for what values make this function equal to 0, or sorry, not equal to 0, equal to y for the graphing purpose. But y is really equal to 0 when we're solving, right? So we're trying to find those solutions. We're going to do the same thing when we are looking at a trig function. So this is 2 sine x plus 1, okay? So I took sine of x, it's been multiplied by 2, and added 1, so we've shifted it up one space. Again, we're going to learn how to graph this pretty soon. When we want to look at the solutions, we're again looking for where does it cross the x-axis, right? And if you look at your little wrench here on Desmos, you can choose from having your x-axis in radians or in degrees, okay? Either way is fine. I'm going to choose radians. We're going to stick to strictly radians for today's work. And if you want to know where the solutions are, click on those zeros or the x-intercepts. You have one at 7 pi over 6 and 11 pi over 6, 19 pi over 6, 23 pi over 6. So if you notice, from 7 pi over 6 to 19 pi over 6, they added 12 pi over 6. Well, 12 pi over 6 is the same as 2 pi, right? Same with 11 to 23, they added 12 pi over 6. If I continue, that is going to keep happening all the way along. So there's an infinite number of solutions to trigonometric functions because these functions are what we call periodic. They continue in the same fashion with the same function values forever and ever and ever and ever. You could keep scrolling Desmos till your fingers fall off. You're never going to run out of graph, right? So let's talk about what that means algebraically, all right? So again, we're thinking about functions on their own, like y equals sine x. Y is the function value, so the sine is the function value, and x is an angle. So that's really important here. What we're looking for, what we're trying to figure out is we're trying to solve for the angle, right? X is the angle. So if I asked you a question like, hey, evaluate the sine of pi over 6, you would tell me, all right, so got to look at my unit circle. Here's pi over 6. The sine is the y value, so we would get 1/2, right? So here, if I reverse that and say, when you're solving, we're really just saying, all right, then if the sine of something, the sine of this x, which again is the angle, is equal to 1/2, what's the angle that created that, right? So if we reverse that thinking, well, the sine is 1/2 here. And if I go all the way around my unit circle, the sine is actually 1/2 over here as well. So when I get an answer like this, then I know that x has to be the radian value or degree but in this case we're going to stick with radians, that created that. So x would be pi over 6, right? These should be equivalent expressions. But x could also be 5 pi over 6, right? And let's say x is pi over 6. That gave me the sign as 1/2. What happens if instead of going just up to pi over 6, I go all the way around the circle and then back to pi over 6? Well, here I went 2 pi radians all the way around the circle, and then another pi over 6 radians, right? I still have the same sign value because these functions are periodic. And we could continue doing that. I could go another 2 pi and up pi over 6, still the same function value, still the same sign value. So when we write the answers to these equations, we wouldn't just say pi over 6 and 5 pi over 6. We're going to say plus 2 pi n, which means we could add on any multiple of 2 pi, and we're still going to get the same sign value or cosine or whatever we're dealing with. So when you write your answers, you're going to first find the angle, and that's what goes here. And then we're almost always going to add on plus 2 pi n, because we could go all the way around that circle again, get to the same point. We have the same function values. You know that they repeat, right? So we're looking for angles just like when we were looking at Desmos. All of these values here, those are all angles, all those x values. Those are going to be our solutions. So they're giving us the y value. We're looking for the x value, okay? All right, so let's try some. So the first type of question is going to say, verify the x value is the solution of the equation. So my equation is 2 cosine x minus 1 is equal to 0. And the x value, or the angle they want me to verify, is 5 pi over 3. Well, if I'm going to verify, the first thing I'm going to do is substitute in 5 pi over 3 where I see x. So I have 2 cosine, and then instead of x, I have 5 pi over 3 minus 1 is equal to 0. All right. Well, now I have to evaluate. I have to figure out, hey, what's the cosine of 5 pi over 3, right? So using all of those little tricks that we talked about with your trig reference sheet, all of those pieces from the unit circle, let's go up to our unit circle and find 5 pi over 3. Let me get rid of all this crazy writing here. We're going to look for 5 pi over 3, which is here. And we're looking for the cosine. And remember, points on the unit circle, the cosine is the x value. And the sine is the y value, right? So we're looking for the x value, which is 1/2. So I know the cosine of 5 pi over 3 is equal to 1/2. So then I can substitute that, right? If they're equivalent, I can replace that in my equation. So this becomes 2, but instead of writing cosine of 5 pi over 3, I'm going to write 1/2, because that's what it's equal to. And then minus 1 is equal to 0. Well, 2 times 1/2 is 1. 1 minus 1 is equal to 0. So we verified that this x value, this particular angle, is a solution to the equation. Now I want to think about this in a little bit of a different way, all right? Let's say we try and isolate the function, and that's what we're going to mostly be doing today, is thinking about how can I isolate this trig function, see what it's supposed to be equal to, and then go back and find the angle, sort of undo the operation. Well, it's 2 times cosine x, and we're going to treat this is like one piece. So think of this equation as 2x, or well, we won't use x. Let's do 2y minus 1 is equal to 0, okay? If you were going to solve this equation to isolate the variables just are unknown, and cosine x is our unknown, then we'd get 2y is equal to 1 from adding 1 to both sides, divide by 2, and y is equal to 1/2. Well, the same thing would happen here. I'm going to add 1 to both sides. So 2 times cosine of x is equal to 1. Divide by 2. So the cosine of x is equal to 1/2. And now we want to think, well, x was supposed to be 5 pi over 3. Is the cosine of 5 pi over 3 equal to 1/2? Excuse me. Well, we said just by looking at our unit circle a minute ago that, yeah, that absolutely is true, right? The cosine of 5 pi over 3 is 1/2. So that's another way to verify this. There's not really one right or, well, I guess there's some wrong answers, but there's not just one right answer to this verification. So think about some ways that you could do that in those first few problems. And then we're going to focus on solving some of these equations without having given us an angle to verify, all right? So square root of 3, secant of x plus 2 is equal to 0. That's my equation. So your first step when we solve these without having been given an angle is to isolate the function. And remember, this of x, this isn't multiplication, that's the input for the angle, so this is all one piece, okay? So the first thing that I'm going to do, I see the square root of 3 times secant of x plus 2. I'm going to take away 2 from both sides. And I have the square root of 3, excuse me, times the secant of x, is equal to -2. Now it's the square root of 3 times the secant of x, so I can divide that away. And I get the secant of x is equal to -2 over the square root of 3. Well, if you think back to your trig identities there, remember that secant of x is the same as 1 over the cosine of x, or essentially they are reciprocals of each other. So if the secant of x is -2 over the square root of 3, then the cosine of x has to be negative square root of 3 over 2. All right, so we have isolated the function, and for our unit circle purposes, it's going to be really helpful to put them into terms of sine and cosine. So if you need to use a trig identity like we did here, try and use one of those to put them in terms of sine and cosine, and that helps us use our unit circle. Now what we have to do is find the angle, or find x. So if the cosine of x is equal to the negative square root of 3 over 2, we want to know what x equals. So let's go to our unit circle, and we have to look for negative square root of 3 over 2 as the cosine. And on our unit circle, that's the x value. So negative square root of 3 over 2. If you look around the unit circle, where is that in the position of the x value? Negative square root of 3 over 2. I see it here. And I actually also see it here. Okay, so most of the time there's going to be more than one answer. There may be as many as 4 answers to the same problem. So negative square root of 3 over 2 comes from 5 pi over 6 and 7 pi over 6. That's where the cosine is negative square root of 3 over 2. So remember that, 5 pi over 6, 7 pi over 6. So our answer is 5 pi over 6. We have 2 answers, and 7 pi over 6. But remember, I could go around that unit circle another full rotation and get the same value. So I want to add on to the end of these both, plus 2 pi n. All right, and that would be your answer. That would be your solution. If you want to check your answer, well, I'll post the answers below, the practice, but you could also put this into Desmos and see where your graph is hitting the x-axis. It should be at 5 pi over 6 and 7 pi over 6. All right, let's try another one. So this one has a squared value. Oops, and I forgot the variable. tangent squared x. So again, our goal is to isolate the function. So I'm always going to start by adding and subtracting stuff away. So 3 tangent squared x, and this is the same thing as if I had the equation 3x squared minus 1 is equal to 0. Right, or I won't use x because that could get confusing. We have too many x's going on. 3a squared minus 1 is equal to 0. We'd add 1. 3a squared is equal to 1. Divide by 3. A squared is equal to 1/3. Take the square root, and so a is equal to plus or minus the square root of 1 over the square root of 3, or 1 over the square root of 3. All right, plus or minus. So doing the same thing here, we added 1 to both sides. Then I'm going to divide by 3. So tangent squared x is equal to 1/3. You can take the square root of a trig function. So the tangent of x is equal to plus or minus, every time we physically take the square root, the square root of 1, which is 1, over the square root of 3. Right, so this time it's asking me for the tangent value, and I actually could get a positive or a negative answer, okay? And remember what I said before, we want to try and rewrite this in terms of sines and cosines. So use your trig identities. Tangent of x is equal to the sine of x divided by the cosine of x, right? So the tangent of x is sine x over cosine x. That's got to be equal to 1 over the square root of 3. And we've done some practice with this before, figuring out, okay, which angle in the unit circle would give me a tangent of 1/3? Well, it's going to have to be one where the sine is 1/2 and the cosine square root of 3 over 2, because then those 2's will cancel out. Because if the sine of x is 1/2 and the cosine of x is the square root of 3 over 2, well, if we multiply by the reciprocal, those 2's really cancel, and we get 1 over the square root of 3. All right? And we can have either positive 1 over the square root of 3 or negative 1 over the square root of 3. So that gives us a lot of options for answers from our unit circle. So my sine then could be, and that's the y value, remember, could be positive 1/2. Positive square root of 3 over 2 is the cosine, or negative 1/2, negative square root of 3 over 2 as the cosine there. So these 2 points would give you the tangent, that's positive 1 over the square root of 3. The 2 points that would give you negative 1 over the square root of 3 would be if one of these values was negative but not the other. So like negative square root of 3 over 2, positive 1/2, or square root of 3 over 2, negative 1/2. All right? So let's take a look at our unit circle. I'm going to bring it in right here and see, see which ones it gives me. There we go. All right, so the points that are going to work here, we have square root of 3 over 2, positive 1/2, so that's pi over 6. Negative, negative, square root of 3 over 2, negative 1/2. 7 pi over 6. Kind of makes sense, they're across from each other. And then negative square root of 3 over 2, positive 1/2 is 5 pi over 6. Square root of 3 over 2, and negative 1/2 is 11 pi over 6. So all the pi over 6 answers give us, or all the pi over 6 angles, give us the right answer. So a couple ways we can write this. Then we know x is equal to pi over 6 plus 2 pi n. We know it's equal to 7 pi over 6 plus 2 pi n. We know it's equal to 5 pi over 6 plus 2 pi n. Or we know it's equal to 11 pi over 6 plus 2 pi n. All right. Now I know that's a lot of writing for us. So maybe we could think about if I took just pi over 6 and I added on 1 pi, well, that would be pi over 6 plus, 6 pi over 6, which is 7 pi over 6. Well, that gives us this second angle here, right? Same thing if I did 5 pi over 6 and I added 1 pi, then I would get 11 pi over 6. So if we wanted to simplify our lives a little bit, then we could just take those two smaller values, so pi over 6, and say instead of adding 2 pi n, because we have all four angles, we can just add on pi n, and that will give us the other two. And 5 pi over 6 plus pi n, that will give us the other ones as well, okay? So both of these would be perfectly acceptable answers. This is just a little bit simpler to write, but if your brain is more equipped at just finding, hey, which angles are going to give me the right values, write that angle down and add 2 pi n, it's perfectly fine. You'll get the exact same answers, okay? I missed an n here. So that's the second way that we could do it. I know that gets a little bit more complicated, but think about the process is the same. We're isolating that function, okay? Just as if the function were a variable, isolate the function, and then look for the spot on the unit circle that gives you this value. The angle is your answer. That's your solution, okay? All right, let's try another. So this time I want you to think, if I give you factors like x times x minus 3 is equal to 0, and I asked you what are the solutions or what are the zeros, you would separate each part. You might do this in your head at this point, but technically you're separating each part. So one of the answers or solutions is x equals 0 from this first factor, and the other is x equals 3 from the second factor, right? We're going to do the exact same thing, but we're going to do it with trig factors, okay? So let me get rid of this, and let's talk about these two up here. So the first factor is sine x, so I'm going to make two equations when it's factored out. Sine of x is equal to 0, and then the second factor is 2 cosine squared x minus 1, again, set it equal to 0. So all this really means when it's factored out is that you have to do twice the work. You have to solve two separate little problems. And I didn't give you any problems where you have to factor it. They'll already be factored for you. So look for parentheses to separate that out and make two separate equations, okay? So sine of x is equal to 0. That's the first one. So what is x? What angle do we have when the sine is 0? Again, if you've memorized your unit circle at this point, you might know. But if you haven't, let's look at our unit circle somewhere. Where is the sine? 0. So remember, the sine is the y value. I see one here and here. So then I know x is equal to 0, or radian of 0, plus 2 pi n, or x is equal to pi plus 2 pi n, okay? There's only 2 this time for that particular x value, so I can't say plus pi n because then I wouldn't, actually, no, maybe I can. I can say x is equal to 0 plus pi n, and if we add any multiple of n, that would give us pi, 2 pi, 3 pi, 4 pi, so that would give us all the pi's that we want. So actually that does work. Sorry, I take back my words. And you don't really need the 0 plus, it could just be pi n, okay? So that's the first part. The second part, we have 2 cosine squared x minus 1 equal to 0. So again, treat it as if we had 2. B squared minus 1 is equal to 0. Solve it for the variable. In this case, this is one piece here. So I'm going to take away the 1 by adding it. So 2 times cosine squared x equals 1. Divide by 2. Cosine squared x equals 1/2. And then isolate the function by taking the square root. So the cosine of x is equal to plus or minus, well, the square root of 1 is 1, and the square root of 2 is 2. All right. If I rationalize this, then we know that the cosine of x is equal to plus or minus the square root of 2 over 2. So looking at my unit circle, we have to see where is cosine equal to positive square root of 2 over 2. Well, that would be here and here. So first two answers are pi over 4 and 7 pi over 4. And then the other, where we have negative square root of 2 over 2, is going to be here and here. So 3 pi over 4, oops, and 5 pi over 4. All right, so stop and think about, is this one where I can just say plus pi n, or do I have to do plus 2 pi n to all 4 answers? Okay. Think about how you could get from one value to the next. And when you do that, you can try and figure out your final answer. It's perfectly fine to write it as plus 2 pi n on everything. All right. But we might not actually have to if we can add a different value, okay? All right, and then one more. Oh, actually, I think that's about it for this first piece. I'm gonna make a second video if you wanna try some of the challenging problems. You can take a look at this, and otherwise go ahead and tackle your practice, and then there's a quiz at the end with a couple questions.